तो आज था लीड कोड क्वेश्चन 1386 सिनेमा सीट एलोकेशन। बड़ा सा थ्योरी लिख रहा है, पढ़ने में ऐसे ही लग रहा है बड़ा सा, बट ये क्वेश्चन अच्छे से पढ़ना, इसमें बहुत सारे अच्छे से हैं। ओके, so what we have given is name as n row of seats numbered from 1 to n. Okay, so we have basically n rows numbered from 1 to n, 1 2 till n. Okay, each row has 10 seats. Basically every row has 10 seats. Now we have given the seats which are reserved in array, reserved seats, which row and which seat. Okay, a four-person group must be assigned four seats in the same row. The group can be seated in any one of the seat blocks. So we have to assign, right, a block of four, and that can only be seated at either 2 3 4 5, 4 5 6 7, or 6 7 8 9. Only these seats can be used to sit that block, and only use if none of the seats are भाई एक बंदे को दूसरा बंदा तो बैठाएंगे नहीं. Then we have to return an integer denoting the maximum number of four seats that can be assigned. That means, let's say you have a row 1 2 3 4 5 6 7 8 9 10. Now you can only place either at here or at here, right? Starting 2, starting 4, and starting 6. So you will know one, note at 10, it either starts from 2, or it starts from 4, or it starts from 6. Now if, let's say, this seat is occupied, now that means this block, right, 2 to 4, this is invalid. Now if among 4 to this 4 to this block, particularly this block, if let's say this block has all seats empty, you can choose this. But if you choose this, then you cannot choose this, right? No. So that means either you can choose block to completely this block and this block, or just one block, right? Okay, so that's it. Now constraints are, in this question we have given n less than 1 in 9. That means n is very big, and those reserved seats we have given minimum of 1 in 4, comma n. So what does it mean? That means if you loop over each row, then you are going to get TL. If you loop over each row, that means we cannot loop over each row. Now reserved seats, that is 1 in 4. That means we can loop over each reserved seats row. So let's say my reserved seats are some rows of 1 comma some x, some 3 comma some x, and then some n comma x. Now the thing is, this unique seats 1 3 some 4 some 1 9 1 7 till n, they, right, they will be less than 1 in 4 only, always 1 in 4. So this is simple. That means we can easily loop or reserve seat. This gives us idea that for non-reserved seats, so for non-reserved rows, that means any row which has none of the seats reserved. What is its contribution? Contribution equals to what? Say you have a row which is completely empty. You can start from 2, you can start from 4, or you can start from 6. So what is the maximum number of families that you can sit in an empty row? So you can put this 2 to 5, 1, or you can put this one, or you can put this one, right? So if you put this one, then you cannot put those ones. So maximum will be put when you pick this one and this one. I start from 2, another family start from 6. So maximum what? 2 families per row. 2 families per row. Now let's say then contribution equals to what? N minus what is the number of distinct rows, whatever it is, n minus distinct rows in reserved. Okay, multiply by 2. Now this is contribution by completely empty row. Now we have to find the contribution by a row which is at least one seat reserved. Okay, let's come to the second part. So we'll make it clean. Contribution by a row that has at least one seat reserved. Okay, so now tell me, in this reserved seats array, it can be given in any order, right? Let's take this example and understand. So we have given n equals to 3, and we have given 1 2 1 3 1 8, 1 2 1 3 1 8, 2 6 3 1 3 10, 2 6 3 1 3 10, right? Only this much, right? 2 6 3 1 10. Okay, then so if you make this is our first row, this is our second row, and this is our third row. So now first row, second seat is occupied, third seat is occupied, eighth seat is occupied, second, third, eighth. Now in the second row, only sixth seat is occupied, and in the third row, first seat is occupied and 10th seat is occupied. Now see, none of these are completely empty. None of these are completely empty. So how much each row contributes? So in this first, if we see, what was our first block? First block is 2 3 4 5. This is the one block. Second block is 4 5 6 7, and third block was 6 7 8 9. So from where we get this blocks, this we have given in the equation, but only on these we can make them set. Okay. Now tell me, is the first block empty here? B1 is empty? No. No. Tell me, can I use 4, 5, 6, 7 here? I can use 4, right? Empty, 5 empty, 6 empty, 7 empty. So is this completely empty? So can we use this block? Yes. So one block we found. Now can we use 6, 7, 8, 9? No, we cannot. No. Come to the second example. Second row. Second row, can we form this B1 block 2, 3, 4, 5? So yes, we can form this 2, 3, 4, 5. Yes. So then we got two blocks now. Can we form 4, 5, 6? No. 6 is occupied, so this cannot possible. Again 6 is occupied, so this is also not possible. Okay, now come to the third row. Third row, 2, 3, 4, 5. Can I use B1 block? Yes, I can use this block. Now, can I use a B2 block? 4, 5, 6. See, 4, 5, 6, 7. None of these seats are occupied, so I can use this block as well. B2, yes. Now, can I use 6, 7, 8, 9? Yes, I can use, because see, this is also not occupied, right? 6, 7, 8, 9. None of these is occupied. Now, what is the max? Max family is that either I choose B1. See, max can be when I choose B1 and B3. If I choose B1 and B3, then contribution equals to what? 2. But if I choose B2, then only one family can be set, right? If I choose B2, then these overlap, so uh, I cannot choose both of them. So if B1, B3 is present, then we choose contribution 2. Otherwise, if any one of them, otherwise, right? If anyone is empty, we choose one contribution, because see, if let's say B1 is false, so only I can choose one among these one, right? This true or low. If B2 is false, then the case is B1, B3, yes, then contribution 2. Otherwise, only one of them can be true. The same case, if B3 is false, among B1, B2, I can only choose one. So the answer will be what? 1 we get from here, 1 we get from here, 2 we get from here. So answer will be 4. So that is our answer output is 4. So now we understand what we are trying to do. For each row, we check if this block can be, if this block is empty or not. Okay. Okay, so let's go and see the how we are going to do this. One thing you will notice, right? We need to find each row. So for each row, we are going to use a map integer. Then we need to know which seats are reserved. So we can do a list of integer. Okay. Now what we store? We store, see, in this first 2, 3, and 8 are occupied. So I'm going to store 2, 3, 8. In second row, 6 is occupied. In third row, 1, 10 is occupied. So these are occupied now. So when I loop for each row, for each occupied row means any row that is present inside our maps, what we are going to do, we check, right? For each seat we have to check. We have three blocks, right? We have block 1, 2, 3, 4, 5. We have block 2, and we have block 3. So we have to check if any seat is reserved from which block. If, right, if first condition we do what, if this seat, right, if this seat lies in B1, then, right, B1 equals to false. That means B1, no, we cannot put this family in B1 block. Similarly, if it lies in B2, we do B2 equals to false. If it's lied in B3, we do B3 equals to false. Correct? Now, again, what was the contribution that we checked? See, if B1 and B3, if both of these are true, that means contribution was what? 2. We have seen here, right? If B1 true, B3 true, we can use this one and we can use this one. So the contribution was what? 2. Now, otherwise, the contribution can be 1 only, and that is if any one of them is present. Otherwise, what? If any one is true among all these, then the contribution will be what? 1 only, right? So this is it. So that's simple approach. You first have to prepare a map of integer list that you can simply just do a loop override. For you can do just simply a loop or whatever, right? Reserve seat, then you can just map or whatever. If you are using C++, you can just simply do r of 0 dot use pushback. If you are using Java, you can simply do add, whatever. That's based on which language you use. So that's how we are going to do this. Now, this is the one approach, and the time complexity will be, what is the time complexity? So time complexity is the occupied rows, right? Whatever is the number of distinct rows for this reserved seats, basically. So we'll write, right, big of what? Big of reserved seats is your time complexity. Space complexity multiply by this 10, whatever, it does not matter, right? The space complexity will be what? So I am going to set R of R into 10. This is going to be the space and time complexity. Now, is there a better way to do this? Is there a better way? Yes, there is another approach, and if someone asks you this question in an interview, you can use that approach. That shows basically your you know about the advanced concept, that is we are going to use bit masking. Now how we are going to use bit masking, and why are we able to use bit masking? So let's see, we have 10 rows, right? So can I write 10 rows as 0 0 0? This, can I say this, right? This integer, this is binary representation of a number 0, right? Integer in binary. Can I say this each bit represents a seed? Each bit represents a seed. Is this correct? Okay. Now, when I say for row R, seat J occupied, or I am going to say it as seat 3. So what this number will become? 0 0 1. Correct? Now this is occupied. Set bit means it's occupied. Set bit means it's occupied. And how do you set a bit? So you can set a bit, when we do right shift operation, that means we multiply. See, kind of, let's say there is a 1, you do 2 into 2 raised to power 8. That means what? Initially you have a number like this, 0. Let me take a simple example. So you do, initially you have a number this 0 0 1. When you do 1 multiply 2 raised to power 3, what you do? You set this third bit. You do 8, right? Then 8, what is the representation of 8? 1 0 0. Correct? This is 8, right? 2 raised to power 0 1 2, right? So that means you move this 1 to right, right? 1 to right side you move. Now, if I have to set this third bit, what I have to do? So initially I had 0, I have to take OR operation. OR operation, what is 0 1? If you take OR with 0 0, OR operation, what you get? 0 1. OR basically set any bit at each position. If both any bit is set, it gives us the result set bit. So that is 0 or 0 is 0, else it is 1 always. So you do 0 OR operation with what? If you need to set this bit, right? Now this is seat 3, but you have to set it from this, right? So you are going to write is 10 minus 3, which is 7. Right? 2 raised to power, how many you have to move? 7. So you are going to do 1 operation, 10 minus 3. This will give us this result, right? So yes, that's it. So this is the word bitwise operation that you are going to use. Now, in the end, what we will have for row 1? So row 1, after setting this, so after setting 2, 3 and 8 bit, you are going to have 0. Second bit is set. Third set is set. 4, 5, 6, 7, 8, 9 and 10. So that 1 means these seats are occupied. And 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in the third one, so this is the same thing, right? Then what we have added in the number, we just represented it in bits. Now, if we have represented, now how to find if the bit is set or not, if the block is empty or not? What we can represent our block? B1. Can I say B1 as 0 1 1? That means I need these seats. I need these seat empty. Similarly, B2 can be written as, similarly B3 can be written as, like B3 you can say 1 1 1 1, and this can be correct. Now, if this is 1, if I need to find if 1 and B1, between row 1 and B1, if I can, if I have to find these seats are empty or not, what is the best bitwise operation that we can do? AND operation, right? Why AND operation? 1 and 0 is 0. 1 and 1 will be 1. So that means if you take B1 and row 1, it will give either as, right? If see, if any of these bits, B1 these bits, if any of these bits are set, we will get a non-negative number. If we get a 0 number, that means all of these bits are 0, then only we get the 0, right? Otherwise, if anyone is set, we simply get 1. So B1 and row, if this is equals to 0 means B1 can be occupied. Now once we occupy B1, we set these bits. Since we already occupied these seats, right? Now we write as row 1 equals to 0 1, and we say 0, right? That means these are now occupied. Now let's see the what happens. So this is the approach that we are going to use. So what we do for similar, the above approach, for each unique row, for each mask is what? These are our mask. For each mask, we check if the number and operation of mask, if this is equals to 0, then what? We increase our answer and we set this. We do XOR equals to mask. That is, now we set these bits and we simply return the answer in the end. So how did we set a position using this, and how did we find it again using this? So that is the approach for bitwise. And what will be the time complexity here? Time complexity will be of this R only. Space complexity will be of R. R is for the reserved seats. And why? Because now we don't have to use this 10 1. So this will be a highly optimized approach. Understood? Let's see the code part. Code part is again, so we have already seen, right? This was the mask, and we have to set these bits. So we'll use Java. We can use CPP, that does not matter, right? We use unordered map, we need int, right? Now, we have to loop out this reserved seats. So what I can say for vector int r in what? Reserved seats, int row equals to what? Row equals to what? R of 0. And what is our seat equals to R of 1. And now we have to set this. So we'll do map dot row. So what we are going to do, or equals to, we have to take or operation with what? We have to 10 minus 1, 10 minus seat, right? That will set it. Now then our answer will be, initially answer will be what? We have seen, right? N minus whatever testing that is occupied, multiply by 2, and then we have to return the answer. But now for each row, right? For we have to loop over the map. So we'll do for int x in map, right? Then for each we have to do the, for each mask we have to loop for each int m in what mask. So what we are going to do, if x and m equals to 0, then what we are going to do, answer plus plus, and we have to set this. Correct? Is this correct? Is this loop correct? int, or do we write this x dot second? So recently I'm doing in Java, so I'm just shifting. What they said, there is no variable conversion, right? We use auto, then we use, right, auto iterator x dot mask int x equals to iterator dot second. Okay, then we submit. Let's see. I think it will work, right? This is quite the straightforward approach. You see. Oh, still we are not 100% right. So people, what did they use? They use the same kind of approach only. It's similar only. If you will see some random, they did the mask, they checked the mask, they shut the mask. Same approach. Yeah. Thank you.